Okay, let's talk about dummy variables and interactions again. I just want to go through a couple more examples, just so we get a little bit better idea. Like I said, we're not going to calculate any of these things by hand. It's just important that we can understand the definitions and how to draw interpretations. So we already discussed a dummy variable is a categorical variable, uh, two categories, yes, no, on, off, things like that. And we assume equal slopes across the different levels of the dummy variable. So let's just look at another example. So if we wanted to estimate pie sales from the price of the pie and whether it's a holiday, so it will be equal to 1 if x2 is equal to 1 if a holiday occurred during the week, and 0 if no holiday occurred during the week. So as we saw, it's very similar to our example. We have the same slope here, but we have different intercepts. So we can see that sales are higher for the holiday pies compared to the non-holidays. And so we're seeing the same slope. These two lines are parallel. However, we have a difference in the intercept. And so we can say if beta 2 is rejected, then we could say the holiday has a significant effect on pie sales. So let's just look at output for this. So this is just a regression output, and I just want us to get comfortable with interpreting this. So let's just focus our attention on this bottom table. So we can see we have coefficients. So we have a negative coefficient on price, which makes sense. This is saying if you lower the price, you'll sell more, and that makes sense. And this is saying is if it's a holiday, we'll see a jump in sales by about 90. So we can see our estimated equation up here. Sales hat is equal to 548 minus 26 times price plus 90 times holiday. So let's focus on this holiday coefficient, which is that on average, sales were 90.1 pies greater in the week with a holiday compared to weeks without a holiday, given the same price. Now, all we need to do is look at this p-value column to determine if it's significant or not. And let's stick with 5% level of significance. We can see that both of these variables are both significant, as both p-values are less than 0.05. So we would say that the holiday effect, that dummy holiday variable, is statistically significant at the alpha 0.05 level of significance. Okay, and then we're going to skip more than 2 levels for a dummy. So now let's go to interactions between different variables. So we saw that in our interaction model, we've got 2 variables, x1 and x2. But then we make a third variable, which is just the cross product of the 2 variables. All that means is we're multiplying the 2 variables together to get the interaction variable, x1 times x2, and it gets its own slope coefficient, b3. And let's just recall the definition of an interaction between 2 pairs of variables. Response to one x variable may, or I kind of prefer my definition, which is that the response of one x variable depends on the levels of the other x variable. So let's go ahead and look at an example. So let's look at house prices. So our response variable, our y variable, is asking price for the home. And our explanatory variables, the first is living space, and whether or not the house has a fireplace. So it is equal to 0 if no fireplace, and it's equal to 1 if there is a fireplace. So if there's no interaction term, then we would assume that the effect of living space on asking price is the same regardless of whether it has a fireplace. But if this isn't true, then the model would need an interaction term, meaning the effect of living space depends on whether there's a fireplace or not in the home. So we would test whether beta 3, which is the slope coefficient on the interaction, is different from 0. And we'll say whether it is significant or not. So let's again focus our attention on this table. So we can see living space. So if you increase living space, that increases the asking price of the home. That makes sense. Fireplace is 34, so it's positive. So if you have a fireplace, that also increases the price of a home. That might also make sense. And then we have living space times fireplace. So this is our interaction term, living space times fireplace. So we want to look at our p-values here. And we can see that living space is significant. We can see that fireplace is not. But let's focus our attention on the interaction. We can see it's 0.74. So this is not less than alpha of 0.05. Therefore, we would say it is not significant. So right here we say interaction is not significant because the p-value is 0.74. So what that means is that the effect of living space on asking price does not depend on whether or not the house has a fireplace. So this means that we would have that example where both our two lines are parallel to one another. You can think we'd have fireplace up here, non-fireplace down here. It is not something like this where the slopes are different from one another. But let's say it was significant, then we would just say the effect of living space on asking price does depend on whether or not the house has a fireplace. So anyway, that's all I wanted to do for this chapter. So if you can just look at the p-value column, determine whether it's significant or not. You can interpret these coefficients. So what does it mean if there's an interaction? What does a dummy variable mean? That's all you really need to know for interaction and dummy variables. In terms of the homework, we're only going to worry about the simple two-variable model, no dummies, no interactions, and that's it for chapter 14.